Hey everybody, thanks for coming. My name is David Liao. I'm a data engineer at GrubHub. I've been here about a year. So I still consider myself really a novice to this topic. And how I got here today is I was trying to learn PySpark, log into our servers, green screen, type in a command, you get some output. It was a really slow way to learn. I didn't like it. So I took some time. I asked the manager, can I figure out how to install this locally in my Mac so I can learn offline and just have a much user-friendly interface? You know, I'm sure half the people here have used Jupyter notebooks at some point in your career or at school. So that's what inspired me to. That's what got me here today. I figured it out. I traversed a lot of rabbit holes. I remember the first time I tried to figure this out, I quit because it got so frustrating. Then I picked it up a week later and figured it out. I wrote an internal wiki page. I shared it with my colleagues. And then I met John, and it got turned into a published blog. But today we're going to have a generalized talk about cluster computing in general and the Apache Spark computing platform. So just some background, this is from a study by Databricks, which is a software as a service Spark vendor. Actually started by some of the original founders of the Apache Spark software. So only 1 in 3 machine learning or AI projects are successful. That's a pretty bad statistics. And it takes quite a while to even get into production. And why don't these projects succeed? Well, too many types of tools you have to integrate. And what would really help is a unified analytics platform. And that's the main business proposition that Apache Spark brings to the table. And I was just recently at the Spark Summit in San Francisco in June this year. And all the Silicon Valley companies that you know of, they've all are heavy Spark users, and they've been in the Spark community probably 4 to 5 years, and they've all developed pretty heavy, deep expertise within their own companies like Airbnb, Facebook, LinkedIn, all those guys. So here's here's an overview of machine learning process. Lots of data to come in, you got to harmonize it, you got to clean it. Then you get into feature engineering, feature selection. Then you start to do model selection, right? You're iterating, checking out different models, looking at accuracy, what's going to work, what's not working. And then you may also apply some business rules on top of that. And then you get into productionizing your model. So what's common here is there's a lot of data to deal with, and there's a lot of data to be transformed at every step. And what are the most common challenges is really large data sets that everybody has there, getting at the data and preparing it in a timely fashion. Data exploration and iterative model training with large data sets. People here are probably familiar with like cross-fold training and things like that. So when you have really, really large data sets, if you don't have a great platform, you're going to probably be spending a lot of time just cranking through the data, not even getting to be able to test your model and train. So we'll just look at the first, this is a long list. Data siloing is personally something I've seen in a lot of different companies in my long IT career. And even right now at GrubHub, actually, we have a similar problem. We have a large Redshift cluster that has been here probably 3 or 4 years. It hasn't worked out for us. We still have a lot of batch jobs on it. And we are actively moving, and it's our team's mandate to get off of Redshift onto our Spark platform, hopefully by end of this year or early 2019. So even GrubHub is suffering from this data siloing problem. So what is Apache Spark? It started as a research project. It became an open source. It's probably the largest open source cluster computing platform framework. And it can handle big data, data warehousing, and it can handle productionizing machine learning models. Why use Apache Spark? If your company already is running some Hadoop clusters, that's great. You can just stand up a Spark cluster and integrate it, because Spark itself doesn't have a file management system. So this previous slide here is showing about, it's really hinting at, you got to choose a database you want to connect to, or whatever your file storage. You want a relational database to connect to, or do you want to use Hadoop or any other kind of distributed file system? Redis is an in-memory database system. You have a choice of languages you want to work in, Java, Scala, Spark's version of Python, PySpark. You can even use Spark R for those of you here who are R people. And it's a lot easier to write jobs in Spark at a higher level language than to do your computing with kind of low level MapReduce jobs, if anybody here has written MapReduce jobs themselves. Now, why is Spark so much faster? I mean, that's one of its biggest value business propositions. Spark can process a lot of its data in memory on each physical worker node, while MapReduce jobs tend to always have to persist their output to disk. So that's typically any kind of input output to disk is typically your slowest point of your production pipeline. So, and when it comes to machine learning computations, you're always quite often iterating over the same data sets. And if you can do that thousands and thousands of times in memory, you're definitely going to get the speed increases that you want to have if you're going to use this kind of platform. So here's an overview of the Spark ecosystem. Below you see the 5 languages. So the Spark core engine handles integration with databases you choose and the file systems that you choose. Handles fault tolerance, and it handles memory management and other low-level tasks. In my team, we mostly are working with the Spark SQL and data frames module. So this is where you can use, because we are using Hive and Hadoop, we're using HQL's compliant version of SQL to get at our physical data. And we tend to load our data into data frames, and people here who've used Pandas libraries know what a data frame is. So the syntax is still very similar. And one practical tip is, I would tend to do my SQL fetch at the very beginning of my job, and then I would take that data frame and I might create a temporary view on it, and then in my next SQL execution, I could use that SQL just like it was a physical table sitting in wherever our file storage system is. And another practical aspect of using PiSpark's version of a data frame is, as Spark itself is getting better and better. For example, windowing functions. People know here, some people must work with windowing functions in SQL. Well, I find the typical SQL version of windowing functions to be really hard to read, but if you use PySpark's version of it, it's really, really much more readable. And as PySpark gets better, you will allow PySpark to take care of efficiencies in the whole platform as PySpark goes from version 2.0 to 2.1, and now we're on 2.3. So this slide is to add something that you can't learn on your own locally on a laptop. I found that 2 other important pillars with working in this type of cluster computing environment is getting used to working with Hadoop Hive file systems. A practical example is you could have a corrupted file. It could be just one column in your file that's corrupted, but you get really misleading errors in your Spark job logs. And even just last week, I had a production table schema that had 1 extra column added to it, but in my development table schema, it was missing, and yet it caused the first SQL fetch to not produce a proper data frame. And again, it gave me a nonsensical error saying, oh, my data frame.count isn't working. But it really was just my data frame schemas were not aligned. The other thing that you can't learn on your own is cluster configuration. It doesn't really come up that often day to day, but even right now I have a really thorny problem where my job doesn't fail on a source code execution line. It just does a memory dump for certain days. And even though I've proven that between day 13 and day 14, the data sizes are really not that different in the fetches, but yet day 13 is giving me a memory dump, and day 14 it runs fine. So that's just, again, some practical hints I wanted to share with you. So why did GrubHub move ourselves out of Redshift into an Apache Spark platform. So the left side is to show our Redshift cluster that has given us some headaches. It's an always-on static cluster, which static clusters have their own benefits, and I'll share that with you. The right side is to show our beautiful, wonderful GDP GrubHub data platform, our Apache Spark platform that has scaled really well for us. So our Redshift cluster is an always-on cluster. It's fixed size. So during the day, it tends to be under capacity. You have all kinds of ad hoc users on it. You have batch jobs that are late, so there's always resource contention. Everybody's wanting power, everybody wants speed, everybody's trying to read, but yet your batch jobs may still be writing to tables and files. We used to have 100 nodes. That kind of configuration didn't work. So now we're actually down to five very large nodes, five of the biggest pieces of hardware you can rent from Amazon. And it's been better, but we still have our bad days. So this is why we wanted another strategy. So why has Spark worked out for us? Well, this diagram is to show different burst cluster sizes. So anybody know what I mean by burst clusters? It means for each individual batch job, people here are probably familiar with the concept of containerization. So each batch job is going to ask Amazon AWS to bring up dynamically a burst cluster that's going to last 1 hour or 2 hours or 3 hours, however long you want. And it's going to be sized for that job's needs. So of course, I have one job that's a 40 node cluster. And thank God the job runs in an hour. So we're not paying too much, right? But if you left a 40 node cluster on for 8 hours, you can imagine how much that's going to cost. So each batch job is getting its own container, and it's a size, that container fits that job's size, so we're saving money. And then you don't have any resource contention. Everything can run in parallel. You're not fighting for resources. Now, we do have static on clusters all the time for any kind of SQL queries that the business users and analysts, data scientists are trying to run against our main data warehouse. So we have a nighttime setting and a daytime setting, and obviously the daytime ad hoc query clusters are going to be a lot bigger than nighttime. But so these are some these were some guidelines we wanted, or things that we wanted to achieve when we built this GrubHub data platform. Clear separation between storage layer and a processing layer. And I talked about burst clusters versus static clusters. But there's actually business cases for all static clusters. One of my colleagues just told me recently that he has a weather job that is churning through weather data for us. We use weather in our delivery process of figuring out our ETAs for how fast we can deliver an order, and also drivers. How long is it going to take a driver to get from point A to point B, and how long is it going to take him to deliver the food. So his weather cluster, because he runs it once an hour, it doesn't make sense to bring up burst clusters because it takes actually half an hour to start up a cluster. So he has a static always-on cluster. And it's pretty big, so it's kind of expensive, but other people found out there's this always-on cluster, so there's other batch jobs that are sneaking onto his cluster and sharing resources. So static clusters also have their benefits. If you size them right and you have excess capacity, why not share it with other batch jobs? So both scenarios are good. It's just about finding the right scenario for the right type of job. This diagram is just like an overview of our GrubHub data platform architecture. It's probably a little small for the people at the back, so I'm not going to focus too long about it. It just really is a visual diagram of everything I've talked about so far. On the right side, I just want to point out that all our batch jobs get ingested into Splunk, and we have dashboards in Splunk that do monitoring for us, and we can search for job log errors in Splunk. We have event alerts, and also we get PagerDuty alerts to our Slack channel when a batch job fails. So we're coming to the end of my talk, and if you want to learn PySpark, how would you go about it? You could rent a computing cluster. You can rent a small one from AWS, and AWS will give you some free time. or you could try to install it locally. You can install it on your Mac or your Windows. My blog that gives you a lot of technical details. If you go to medium.com and search Learn PySpark locally, you'll find the link. But it gives you a lot of details on how to install the software in the right order and the specific environment variables that you have to get up to start a PySpark session inside a Jupyter Notebook. So some hard practical tips. Use Java 8. And it will work with PySpark version 2.0 and higher. Actually, I had to reimage our PC back in April, and I reused my own blog to help me get up to speed quickly again. And actually, I read somebody else recently published use Python 3 with PySpark, and he or she also said that Java 8 was the version they recommended. Find the Spark version you want, and from that Apache Spark download link. And I think it's safest to download it to the user/local root directory if you are a Mac OSX person, because future software installs shouldn't override whatever you choose to put there manually. And I will give a brief demo right now. Are we good for time? I'll just take 2 minutes and go through a brief demo. But afterwards, you can email me, and I'll happily email you a version of this notebook that I'm about to demo right now. DLIAO@grubhub.com. Okay, so let's get to the demo. So I'll bring it up. If anybody has any questions, feel free to raise your hands. So here it is. So PySpark wiki. Sure. So I'm just going to make this bigger. Is that better? Okay. Yeah. Okay, let's expand this all the way, make it full size. How's that? Okay. All right, so just importing the libraries we need. And initially, it's all really just about making sure you have some key environment variables set up. We're just printing out if you have Java Home or Spark Home, and if you even have Python Path, or if you have IPython. So Spark Home is a first important one that you got to get going. And I actually have a link here to where I figured this out from. Next one is the PyLib environment variable. And you want to override or create a Python path environment variable if you don't have one already in your boot up file. So this next one is important. If you're an IPython person, that variable is no longer used in Spark 2.0 and higher, and it's going to cause errors if you don't blank it out. So another important Python variable is the PySpark_Python. I mean, I know it sounds like a lot, and actually even figuring out the right order was what took so long when I first was attempting to install it. So that was why I wanted to kind of document this and help other people get up and running. Now I'm printing out all the rows I have in my Python path variable. There's 2 zip files that should be added. So you have to, whatever version of PySpark you install, you want to find that the zip files are quite similar in the exact path depending on where you install them. And you'll want to do this syspath insert so that the PyLib environment variable is aware of them. Verify that the syspath variables were added. So I think these are the last 2 critical environment variables needed is PySpark driver Python and PySpark driver Python _OPTTS. So we're almost at home base. You need to find this shell.py executable, again, in wherever directory you installed your PySpark. Now you're ready to initialize your PySpark session. And this is a GitHub link that I found out how to do this, and now. Presto. All right, there it is. All right, so maybe we have 2 or 3 minutes for Q&A. Please. Anybody have any questions?
If you have a question, I can bring you the mic.
Well, great. No questions. So.
I have a question.
Sure.
So when did you start playing around with especially the IPython notebook component and started building this for yourself? And about how long did it take you to get to where you're at now?
So I've only been at GrubHub a year, and within a week I was extremely frustrated with command line sessions. So I started exploring this on and off. And I remember I'd spent 3 whole days coming close, but still no cigar. I gave up because I was hitting my head against the wall so much. And then I came at it again and spent another day, day and a half, and finally got it working. And that's why I took all this effort to document it, not just for myself, but for our company. So, and I don't always come here to do some coding, because we have our own very sophisticated job deployment framework. We use something called Azkaban, which is an open source framework that I think LinkedIn published. And we have really good cloud engineers that have kept improving our job deployment framework that I can iterate also quickly with launching batch jobs in a burst cluster. And another good tip to share with you guys is what my team will commonly do is now I'm going to work on this ticket all day today. I'm going to bring up a burst cluster for 8 hours. Yeah, I'm paying for 8 hours cost, but it allows me to keep working continuously. And then I'll just keep making commits to my code base and to keep running a job. And once my cluster is up, I don't have to wait half hour for it to start up. I commit my changes to my source code, I rebuild my job, and I run it again. So, but when I'm learning new syntax, that's when I love to use a Python notebook. And in my blog at the end, I gave you a couple of examples where the syntax is a little unusual, and that would have been really irritating to try to do in a terminal session. So, you know, I still consider myself a novice, and that's why I said that learning to work with Hive, HDFS, and learning cluster configuration is actually, I would say, equally important to working in a complete Apache Spark ecosystem. So there was another question in the corner.
Yeah, is this notebook linked from your blog?
It's not attached to the blog, but just email me at dliao@grubhub.com and I'll email you a version.
A lot of the guides online recommend using like Spark Submit to kick off Spark jobs. Does this procedure prevent you from having to do that, like so you can do it interactively in the notebook?
I would think you can still do a Spark Submit in here. You just won't have a full cluster. It's just going to go. It's only going to use the cores that you have on your machine, and it should set up a driver versus a worker node and things like that, even though physically you only have one machine. But I mainly use the Python notebook. Again, it's to just kind of play around with code offline. I know what you're referring to. So let me see if you're referring to setting up something like this, where you're loading up a bunch of Spark parameters and doing a Spark Submit job. And yes, that is how we would actually instantiate a real Spark job on a burst cluster or a static cluster.
So what are you doing to replace that? Like I missed it.
So to me, the Python notebook is just to learn syntax coding. It's not really an environment to set up a full-blown batch job run. You really need to have Azure, Google Cloud, Amazon to do that. So those are the things you can't learn on alone without a real computing environment. And cluster computing has its own kind of challenges. So how many people here have worked with cluster computing, like your company? So a good 10 to 15%. I'm sure everybody here can. And if you came from a world where you have dedicated Oracle servers, dedicated hardware that your company owns, going to a cloud computing world, it's a big difference. And if you're using cloud computing, you're probably using a distributed file system. So I'll just reiterate this again, because when you're working with like S3 file storage with Amazon, it is not a relational database. It's just a physical file. And anybody can wipe out your files with a simple command. Files get corrupted for no reason, and you don't know why, but you got to deal with it. And your job log's not going to tell you that your file's corrupted, but you'll eventually figure it out. But those are just the headaches of cluster computing, cloud computing.
We got one more question over here.
Okay.
Hi, David.
Hey.
My name's David. I work as a data scientist at Avant. And firstly, could you please stop stealing our best tech talent? Secondly,
I don't know what you're talking about.
Secondly, I was wondering if you could please maybe expand a bit more on the benefits of installing Spark locally on your computer versus using it elsewhere.
Well, how many people log into a server and have to look at code like this? Right. So it looks like the majority aren't having to log onto a remote server and do command line type of coding. It's just slow. Okay, let's bring up something else. Okay. So this is a high table schema definition, but you type in a command and you get rows and rows of rows, and then you can't actually save your work either, right? Because your screen is going to only memorize so many lines. So what I love about working in this kind of environment is you can save as many versions of your notebook as you want. I did that all the time when I was doing my data science studies, especially if you're an analyst and you're visualizing stuff. So that's something I can't do in a burst cluster in a batch job, right? But here I could read in a simulated table as a CSV file. I can do my visualizations in my notebook, and I can save my work and go back and reference it. And actually another thing I love to reference is to save my error messages in a notebook. And I have an example of something that crapped out, and I can reference it again. Versus, trying to save code and output sessions in a terminal screen is just a really inefficient way to work, in my opinion. So, it's about making yourself learn faster, really. That's what led me to this. Well, thanks, everybody. I want to have time for the next speaker. Thank you.